Okay, so let's continue with a general equation of each of these shifts that we did. If you look at the first equation that we worked with, of course, the first one was our parent function, but the first one that we actually transformed was y equals x squared plus 2. So if you notice, that is in this form right here, which is f of x plus c. In other words, your constant is separated off by itself. And let's go back. When we said x squared plus 2, what was that note that we said was um, that it had in relation to the parent function? I believe we said that it shifted it up 2 units. So in this case, if you have something in this form, that will be a vertical shift up. Alright, and then after that, we had another form that you've seen previously, and that was in the form of f of x minus c. Realize still that the c, or the constant, is still separated from your f of x, but this time it has a minus, and that actually is a vertical shift down. Okay, the next shift that you're going to most likely experience is in the form of h of x equals f of x minus c. This time, notice that the c is inside with the x. So in other words, you have x minus c. Now remember, if you relate it back to trig, we said that if it was inside with the x, then it always performed the opposite transformation. So in this case, we have f of x minus c. The opposite of a minus c is a plus c. So this one actually has a horizontal shift to the right. Okay, the next one is going to be h of x is equal to f of x plus c. Again, notice that the plus c part is inside with the parentheses, or inside of the parentheses with the x. So we want to think opposite. And the opposite of a plus c is a minus c. So this is actually a horizontal shift towards the left. Then our next one is going to be h of x is equal to negative f of x. Now remember, that's going back to the one that we had y equals x squared, and then we also had y equals negative x squared. We figured out in this case that it was a flip, or in other words, a reflection about the x-axis. And then one that we didn't do exactly, but you will most likely see it, is in the form of h of x equals f of negative x. And that is actually a reflection about the y-axis. Okay? All right, so that wraps up section 1.7, which are transformations of functions. Now what I want to do is I at least want to do an example problem, an example problem, and then discuss your homework. So let's talk about, let's see, new. Okay, so I'm going to basically, to begin with, I'm going to put a set of equations up here, and you should be able to tell me in words what shifts are going on in relation to the parent function. And then it's also going to be vice versa. I may give you a graph, or in other words, I may give you some shifts, and you should be able to actually provide me with that graph. So let's start off with the first one. Y equals x squared minus 1. We always want to get in the habit of typing, or at least writing down the parent function. So in this case, the parent function of this equation that I have here is what? Quadratic. Excellent. Remember, if you don't know anything, at least write down things that make sense, whether it be on a quiz, on a homework, or on a test, so that you can get more points. Okay. Then you have to write down in words the transformation that's happening. Okay, so in this case, it's in the form of f of x minus c. So really this shifts, there is a vertical shift of 1 unit down or downwards. That would be a proper way to say that. Okay, now we're going to have a different equation. So we have y equals, let's have negative x plus 1 squared and plus 1. Okay, so again, for this case, our parent function is still the quadratic function. And let's talk about the transformation or the transformations for this one. I like to start off with my negative. That negative means that it reflects it, so there's going to be a reflection about the x-axis. This plus 1 that's inside with the x, that means we have to think the opposite. So that means there is going to be a horizontal shift. And let me move it this direction. Horizontal shift of 1 unit to the left. And then our next one is going to be the plus 1. That's what we're going to take care of. And that's going to be a vertical shift of 1 unit upwards. Okay, so again, that is a reflection about the x-axis because of the negative, a horizontal shift of 1 unit to the left, and a vertical shift of 1 unit upwards. Okay, moving on. Our next one is going to be x minus 2 plus 6. All right, so let's see what's going on in this case. All right, so our parent function is still going to be the quadratic function. Let's discuss our transformations. I want to take care of this negative, so obviously it's going to have a reflection about the x-axis. Let's take care of this minus 2, which is inside with the x, so we got to think the opposite. So that means it's a horizontal shift of 2 units to the right. And then we got to take care of this plus 6, which is going to be a vertical shift of, shift of 6 units upwards because of the plus. Okay? Alright, so then we're going to do our last one, which is still going to be a quadratic parent function or a quadratic function. And the parent function is quadratic. So we have y equals x minus 5 squared minus 3. Alright, so again, the parent function remains the same, but our transformations have changed. This time we don't have a negative, so we're not reflecting, but we do have a minus 5 here, so that means we have a horizontal shift of 5 units to the left. I'm sorry, to the right, because we got to think opposite. And then this minus 3 is going to be a vertical shift of 3 units downwards. Because of this minus here. Remember the minus in here, we got to think the opposite, so we're actually moving 5 units to the right. The minus here is just as it is, so that means we're moving it 3 units downwards. Okay, so that wraps up this section. What I want to do is discuss your homework. I believe, if I haven't mentioned it already, but I will pick it up on Monday. So this will be due on Monday. We're going to do number 1 probably on Thursday when I come back. And we are going to do it together. So number 1 will be something that will be done by all of us. And then now you should be able to do 2. That's average rate of change, ARC. Remember, change in y over change in x. It's basically like slope. Y2 minus y1 over x2 minus x1. Then we have number 3, which is still ARC. However, now instead of values for x sub 1 and x sub 2, now your t sub 1 and your t sub 2 are letters. You should be able to manipulate and work with letters a lot more, especially in this semester and if you get to calculus, because slowly as time progresses, I'm going to stop including numbers, and basically you're just going to deal with letters a lot. Number 4 is one of them that you should have done also, or you should be able to do, odd or even. Do each one. If it provides you with the original equation, it's even. If it provides you with the opposite, it's odd. And of course, if it's not anything at all, it's neither. Then also don't forget to state its symmetry. Remember that even have symmetry about the y-axis, odd has symmetry about the origin, and neither of course has nothing, no symmetry. Okay, so then we have this next one. Write the new equation, g of x, for the graphs. F of x equals the absolute value of x. So this is your parent function that is shifted up 1 unit, left 4 units, and reflected across the x-axis. You should be able to do this one. Now, this is what I was referring to. Now I'm giving you the shifts or the transformations, and you should be able to show me in graphically what's going on. So I should be able to, first of all, you always want to start off with your parent function. So I should see your parent function. Then I should see each shift or each transformation on your graph. And this is a problem that would be good for you to use different colored pencils or different colored pens if you have them. And I will do one of these when I come back. So you should still be able to do this on your own. If not, I'll do one of the examples. Number 6, again, you should be able to do. What I would do is I would take each of these nice little points right here. For example, find out whatever this point is. Find out whatever this point is. This one right here, let's assume it's right here. This one right here, and then this one. And then once you find out each point, you take each one of these and apply it one by one. This is basically saying you're going to take the entire function, f of x, and you're going to shift it up 1 unit. That's easy because then you're going to shift this point up 1 unit, this point up 1 unit, this point up 1 unit, this one up, and then you'll draw your new function. Likewise, this one is actually shifting it 2 units, but to the left. This one is reflecting it. Remember, it's reflecting it about the x-axis. So what do? You're going to multiply f of x. And what's another way of saying f of x? Remember, in algebra, your teacher has stated basically f of x is what letter? Y. So you're going to multiply your y value by negative, and you're going to still keep your x value, and you should get some kind of graph that has been reflected about the x-axis. And then D will be a compilation of all the shifts. So you should be able to follow that letter D part and apply that transformation. Okay, moving on to number 7, it says determine the parent function. I want you to hold off on letter D and letter F and H. D, F, and H, let's hold on to those, but you should be able to do the other ones.